Good morning, my dear students. Today is the 7th October 2020, and we are back with another exciting session of our online class, and this is for class 12, and the topic is dispersion of light. In the earlier class, I had already sent one PDF note, and I do hope that you have already copied down the note. And in today's class, I'm going to do one more explanation on that. And after that, we'll be talking about this prism formula also. So first, we need to see what is a prism. A prism should be a portion of a transparent refracting medium. It means that your prism should be made of a transparent refracting medium. It means it should be able to produce refraction, and it should be bounded by a minimum of two refracting planes. So in the figure ABC, these two can be the refracting planes here. So this type of unit, optical unit, we call as the prism. So for derivation, our main focus is on this equation: A plus del is equal to I plus E, where A is the angle of prism. Angle of prism is obtained here, the angle between any two planes, the refracting planes. This is known as angle of prism. And angle of deviation means the ray when you produce this ray, incident ray, and when you produce the refracted ray. Okay, let me show here. Incident ray, it undergoes refraction. This is the normal. One more refraction here. This is known as emergent ray, and this is the incident ray. So when you produce the emergent ray and when you produce the incident ray, here comes an angle. This angle is known as angle of deviation. Okay, for the derivation, let me draw a bit better figure. So this is our prism. Let me call it as ABC. Here is the incident ray, and here should be the normal. So this is the normal. So it means by it should be angle of incidence here. I is the angle of incidence. And as the light goes from rarer to denser medium, it undergoes refraction. So this is your refracted ray, and one more normal should be drawn here, another normal, and here comes another refraction. As the light goes from denser to rarer, this is still rarer medium, it undergoes refraction. So this is called as emergent ray, and the angle made by the emergent ray with the normal, this is known as angle of emergence E. So when you produce this angle of when you produce the incident ray, and when you produce, make it longer, the emergent ray, here comes an angle between the incident ray and the emergent ray, and this angle is known as angle of deviation. For symbol, let us write as del here. And for easy derivation, let me mark this ray as P, and this one is Q, and this one let me call this R, and this one is S here. And let me mark this point as O, and here is the angle of prism, and this point is T, for example. Okay, this is our figure. It is done. So now in the first case, we'll look at this quadrilateral AQOR. So in this quadrilateral AQOR, the opposite angles are angle A plus angle of QOR, which is going to be 180 degree here. Okay, and we need to find out these two angles. These two angles, this will be called as angle of refraction R1, and this is also another angle of refraction R2. So we need to find out this upper angle here. We need to find this upper angle here. So to find the upper angle, say TQR, you can see angle of TQR, let us say this is equal to, let us say, okay, let me just add a plus here, plus angle of TQR plus the lower angle is R2, it makes here, okay, the sum of these two, I mean angle of TQR plus the lower angle R1, this sum of the two angle will be equal to this opposite angle here. So we can write as I here. Alright, so this will give you angle of TQR as I minus R2. Similarly, you apply on the right side here. You have one more angle of TRQ. Angle of TRQ plus the lower angle is R2. This is going to be equal to, the sum of the two angles is equal to E again. So this will give you angle of TRQ is equal to E minus R2. Then in the triangle TQR, exterior angle is del. So exterior angle is equal to the sum of interior opposite angles. So you can write this del is equal to, interior opposite angles are these two. So one is TQR is here. So you can write I minus R2. Sum means here plus. I repeat again, exterior angle is equal to the sum of the interior opposite angles here. The sum, you have to find the sum of the two, and the sum of the two should be equal to del here. That's what I'm doing. So the first angle is here, given by this equation, and the second angle is what here. So the other is E minus R2. Okay, so when you open the bracket, you should get I plus E, that's followed by minus R1 plus R2. When you open the bracket, you'll get the same thing here. Alright, this is the one. And in the lower triangle again, in this lower triangle, you have got three angles, R1 plus, another is R2 plus, another angle is here. This was supposed to be 180 degree. Or just say QOR here. QOR, the sum of the three angles in this triangle, the sum of the three angles is equal to 180 degree. 180 degree, it's okay. So this will give you R1 plus R2 is equal to 180 degree minus QOR here. Okay, then let's see, 180 minus QOR, how can you get it here? You can get it from the first equation. 180 minus QOR, from this angle, 180 minus QOR will be equal to angle A. So you can write as angle A here. So R1 plus R2 is going to be equal to A, angle of prism. So angle of prism is equal to the sum of the two angle of refractions. So you can write. So now you put here in this equation of del, angle of deviation. Angle of deviation now is equal to I plus E followed by minus R1 plus R2. I can write as A here. So you can write, you bring it here, A plus del is equal to I plus E. It means the angle of prism plus angle of deviation is equal to angle of incidence plus angle of emergence here. This is an important conclusion. And this is the derivation. So for node, I think you have already copied down. So in the next class, I'm going to talk about this angle of minimum deviation. Let's see. Here. This is all about angle of minimum deviation. Let us see what is this. Okay. Actually, what happened is in the derivation, I plus E is equal to A plus del here. In this equation, here is the angle of deviation. Del is known as what? Angle of deviation. Okay, so this will be replaced by one angle. Del is equal to del M here, and this is what we call as the angle of minimum deviation. Okay, and this angle of minimum deviation, this is associated with one angle of incidence. It means there is only one angle of incidence for which angle of deviation is minimum. Remember, this condition you get it under a certain condition. So suppose this del is equal to del m. How did you get this? You'll get this under certain condition. Let me tell you what are those conditions. Suppose this is your prism ABC. This is the incident ray, refracted ray, emergent ray, and this is the normal, and this is IE here. You'll get this condition if I is equal to E. It means if the angle of incidence is equal to angle of emergence, then you'll get this condition here. Is it okay? And not only this, the two angle of refraction R1 and R2 also, the two angle of refractions also should be equal. It means R1 must be equal to R2 is equal to R here. So these are the two conditions you need to obtain this one here. It means this is the minimum angle that you get when you put I is equal to E and if R1 is equal to R2 is equal to R here. So sometimes usually the question goes like this, say what are the conditions to obtain angle of minimum deviation? It means what? These are the two conditions here. So now we'll put back in the equation here. So I'll be putting is I is equal to E here. So you can write I is equal to E and you try to put here in this equation. So if you put here, you can write I plus I is equal to A plus, and this del is written as what? Del M here, angle of minimum deviation. Okay, so you have twice I is equal to A plus del M here, like this, or simply I is equal to A plus del M by 2. You keep this equation here, and one more. In that equation of A is equal to what? R1 plus R2. You try to put R1 is equal to R2 is equal to R. It means the two angle of refractions are equal. So you can write A is equal to twice R here, or simply R is equal to A by 2. Alright. So now let's try to remember Snell's law of refraction. In Snell's law of refraction, suppose that this is the angle of incidence. Okay, then you try to apply the Snell's law of refraction here. So this is the first medium, rarer medium, this is second medium. So it should be mu. You can write here from Snell's law of refraction. Mu here, the light goes from first to second medium. So 1 to 2, this is equal to sine of angle of incidence by sine of angle of refraction. We know that. Okay, so using these values here, so you can write sine of I can be replaced by A plus del M by 2, all divided by sine of R can be replaced by A by 2 here. So this formula is known as Prism Formula here. Derivation is of 5 marks. So if the question is asking by giving 5 marks, you need to write from the beginning, including derivation of this one. Okay, so you just copy down these things on your notebook, and right now we'll try to solve one simple question based on the theory. You see, suppose there is a ray. There is a ray of light. It suffers minimum deviation while passing through a prism. Imagine like this. There is a prism ABC. While passing through this prism, then what? The ray suffers minimum deviation. It means this angle is what? Del M here, minimum deviation. And the prism material has refractive index of 1.5, and the refracting angle, the angle of refraction here, this angle of refraction, this refracting angle is let us say 60 degree. I repeat again, the prism is undergoing minimum deviation. So angle of deviation is equal to what? Minimum deviation now. And the angle of refraction is found to be 60 degree. And the refractive index of the prism material is 1.5. If you want to copy down the question, you can copy here. I'll just dictate the question. Question looks like this. If a ray of light, it suffers minimum deviation while passing through a prism of refractive index 1.5 and refracting angle of 60 degree, then you find the angle of deviation and angle of incidence. It means you must calculate angle of minimum deviation and the angle of incidence I. You have to find out this one. Okay, so now these are the given information. Now let's just see what happens. Put these values in the Prism formula. Mu is equal to sine of a plus del m by 2 divided by sine of a by 2. And you know, usually in the question, the prism is equilateral triangle shape. So angle of prism is going to be 60 degree here. Then let's say, what can we do? Mu is equal to sine of okay. So refracting angle here also already given here. Refracting angle is 60 means what? This is your angle of prism. You can include that. So sine here, angle of prism is going to be 60 plus del m by 2, all divided by sine of 60 by 2 here. Okay, so it becomes equal to sine of 60 plus del m by 2, let me still write here, divided by sine of 30 degree. That is, and let us put the value of mu here. Mu will be put as 1.5, and let me transfer this on the other side. Sine of 30 degree is equal to again sine of 60 plus del m by 2. Okay, then sine of 30 degree, you can take it as 0.5 or 1 by 2. So when you multiply with 1.5 and 0.5, you'll get 0.75 here. Alright, this is equal to, let me still write it here, sine of 60 plus del m by 2. And this sine, let me transfer on the other side. So it becomes 60 plus del m by 2, this is equal to sine inverse of 0.75. You need to look for one angle whose sine of that angle is equal to 0.75. Actually, sine 48 degrees is equal to 0.75. So 48 degrees should be equal to sine inverse of 0.75 here. So now you can write a sine inverse of 0.75 as what? 48 degree here. 60 plus del m by 2. So when you calculate this, you should get, let me just directly write here. Time is limited, you do calculation, okay? So you'll be getting the minimum deviation around some 48. Right? Around 48 degree you'll get it here. And it'll be okay, 40, slightly should be less, yeah? Let me just check it. Yeah, 40. You have this 48.6 degree into 2 minus 60 degree. Okay, it should be around some 37 degree here. So the angle of minimum deviation, you will get around some 37 degree. Okay, then use it now. Use this angle. I mean, use this equation. I is equal to a plus del m by 2. already derived this one. Look at the earlier derivation. So put it here now. So angle of prism is 60 plus minimum deviation is now equal to 37 by 2. This will give around 48 degree. So what we get is minimum deviation we get is 37 degree, and the angle of incidence we get is around 48 degree here. This is your answer. So you just copy down this question also, and you go through the video at least 2-3 more times so that you understand better.